Mr. Walker, can you help me? Here the weight seems to be centered on my finger.
Here's Richard with his helium atom.
Hi, I'm Richard. I'm going to talk a little bit about the helium atom. The helium atom is made up of 2 positive protons, 2 negative neutrons, 2 neutral electrons orbiting the atom. I think I said that the neutrons are negative. I meant neutral.
Here's Andrew with his egg experiment.
Hello, I'm Andrew Fitty, and I'm here to do this experiment. Now I get to make an idiot of myself. Now you would think that because this egg, hard-boiled, is wider in diameter than the mouth of this flask, I would have to push it with something, physically push it to get it into the bottom of the flask. Well, that's wrong. Trying to put it on there. First, I'll put it on the top. Spit at me. Looks like it's leaking. It's not happening. What? Oh. There it goes. Well, this thing's supposed to hop. It apparently isn't doing that. It's spitting at me. I get it. Alright, now that I've taken this egg off the heat, the egg is now going to fall in. Even though it was larger, it was sucked into the inside. Now if you want to know why that happened, I'll tell you. Because when I put it on the heat, over here, it expanded. And it forced out over the on the one side of the egg. It's supposed to. The egg usually jumps. This egg didn't. Then, as I took it off the heat, the air contracted again and sucked the egg into a point where no air could let in. So instead of the air, the egg ended up sliding through here and into the flask. As it left the mouth, more air went in. Still, who's cracking up? Am I doing something wrong? Well, anyways, the air goes in, and that's it.
Here's Megan with proof that 2 objects cannot occupy the same space.
Hi, my name is Megan, and I'm going to prove that 2 things can't occupy the same space at the same time. See, as water goes down, air bubbles go up. So, how can I make the water go down faster and the air go up faster? I'm going to put a hole in the water so that the water will go down faster and the air will go up faster.
Going to show you some tools in the metric.
Hi, my name is Lisa, and this is a balance. It measures mass. This is a graduated cylinder. It measures volume. And this is a meter stick. It measures lightning. Thank you.
Here's Maria to prove to you that CO2 does not support combustion.
Hi, my name is Maria. I'm here to show you that CO2 does not support combustion. I have a chemical mixture that I already prepared that creates CO2. When I light the spoon and I put it inside, the CO2 extinguishes it because fire needs oxygen to burn.
Here's Sarah with the test for oxygen.
Hi, my name is Mr. Walker.
Hi, I'm Sarah.
And we're going to do a little experiment for you today dealing with the production of oxygen. The 2 chemicals that we will use will be hydrogen peroxide and manganese dioxide. The last experiment we did with CO2. What is one of the characteristics of carbon dioxide with flames? The last experiment. Do you remember?
That was
Right. What happened when we put a burning splint into carbon dioxide?
the flame.
The flame went out. Now we're going to do a test today, which is the test for oxygen. And the test for oxygen is a glowing splint will burst into flame. Now we'll try it to see if we have oxygen present at the start of the experiment. Would you please dip this glowing splint into that container? Okay. As you can see, it did not light up. That means we do not have any oxygen being liberated by the hydrogen peroxide. But if I add this chemical, manganese dioxide, which acts as a catalyst, now I think we have oxygen. Let's find out. What is the test for oxygen?
You put a glowing splint, and if oxygen is present, a glowing splint will burst into flame.
Okay, this is a burning splint. This is a glowing splint. Let's make the final test. And we have it. Would you try it again, please? Get in there. Oh, okay, careful, don't burn yourself. A glowing splint will burst into flame in the presence of oxygen. Thank you for your assistance.
Thank you.
Here's Ben with his rolling can.
Hi, I'm Ben Weiss. I'm going to do an experiment called rolling can. If I would place the can here in the middle of the incline, you would think it'd roll this way. Nope. It doesn't. The reason why it does this is there is a magnet inside. I mean a weight. If I place the weight at the bottom of the can, it should stand in the middle of the incline.